Okay, so let's talk about rotational dynamics. Well, linearly, the sum of the forces is mass times acceleration. So forces cause accelerations. But we know in the rotational world, we have angular accelerations. So, what causes angular accelerations? Well, let's do our rotational analog. I'm using crayons today. So, the rotational analog, we can't see it. The rotational analog of force is this thing called torque. And torque causes angular accelerations. So, a torque is the rotational analog of mass, which is I, which we're not going to cover this semester, but here's I. So now, what does a torque really do? This is torque, T-O-R-Q-U-E, and it uses my favorite letter, tau. So, what about torques? Torques cause rotational acceleration. So, when something, in order to get something to change its position, and I'm going to rotate it around an axis, I must apply a torque. So the torque has two parts. Torque depends on how far out you're pushing. So L, length of your lever arm. In this case, we're going to call that R. It's your lever arm. R is your lever arm. And how hard you're pushing. The force. Now here's the other thing. If I'm pushing this way, there's an angle between it. So if I'm pushing this way, I'm not going to get as much twisting force as I am if I push it at 90 degrees. So it becomes the sine of the angle between the lever arm and the force that I'm pushing. So let's do an example. Let's take a look at your ankle. Your ankle is an awesome torque. Here's your axis that you're rotating around. You have your giant muscle back here, and it's attached right here. This is about 3.6 centimeters away. The distance from where your Achilles tendon is attached to the back of your heel and where your heel rotates around. So this angle here is 55 degrees. The Achilles tendon will pull 750 newtons. How much torque is there? There we go. How much torque is there? Well, torque is the force times the lever arm times the sine of the angle between them. So I have 750 newtons times the radius, which is 0.036 meters, times the sine of 55 degrees. Multiplying this out, I end up with, wait a second, I don't have a direction. So this way is positive, this way is positive, this way is positive. So this torque is going to be in a clockwise direction, so it's a negative direction. When I multiply it out, this gives me 15 units. It's newtons times meters, so it becomes negative 15 Newton meters of torque.